notice, and this is the typical copyright. We continue with mathematics syllabus, May-June 2018 for CSEC. As of December 2025, this syllabus has not been revised, but there are plans to change the structure of the exam from 2028 and onward, with a few pilot projects now being conducted in a few Caribbean countries. The syllabus itself remains unchanged, the contents. The two main changes for the exam are: one, split the exam into two parts, and two, there will no longer be any alternative sections. All sections will be tested. Schedule of videos, sections 1, 2, and 3. All 51 of those videos have been published in their entirety on YouTube. Please make good use of them. Section 4, 5, and 6, those have been published as well. Some completely, and the rest partially. We are now at section 7, relations, functions, and graphs. This is the 16th of 26 videos. And of course, after that, we still have to do geometry and trigonometry. And then finally, section 9, vectors and matrices. Hopefully, all of that will be done by April, May 2026. Please note this disclaimer down here. This schedule is just a projection, and it is not to be interpreted as a contract with anybody. Just a quick reminder that all 33 of the videos from section 1 have been published in their entirety on YouTube, specifically because this section forms the foundation on which the rest of the syllabus is based. So you need to make sure you learn the videos here very well. A reminder also that you need to know the times tables from 2 to 12, since calculators are not allowed in paper 1. Furthermore, as it relates to section 1, some of these videos are even applicable in the primary schools for students, for teachers who may want to use them in the inverted classroom, and especially for parents who may think that they don't know anything about mathematics. For example, if you consider this box here, you may see video 6 says add, subtract, multiply, and divide whole numbers. So that's video 6. But in order to do that, students and children have had to learn place values, which is an earlier video. And then video 7 says add, subtract, and multiply, divide decimals. Video 8, add and subtract fractions. And video 9, multiply and divide fractions, and so on. These are all work done in the upper sections of the primary school, but especially grades 5 and 6. So there is some help here for even the primary school students, teachers, and the parents of those children. As already pointed out, section 2, all 12 of these videos have been published on YouTube in their entirety. Section 3, all 6 of these videos have been published in their entirety. Section 4, only these indicated in yellow have been published in their entirety on YouTube. The others are partially published on YouTube, but you can still learn something from them because it is part of the work. However, if you need to get full access to these videos that are only partially published on YouTube, please see directions in the description below. Section 5, statistics. Again, these that you see indicated in yellow here have been published on YouTube in their entirety. The others only partially, and again, you can still learn something from those that are partially published because they do deal with those specific objectives to a certain extent. However, if you need full access to these videos that are only partially published on YouTube, please see directions in the description below. And the same thing applies for section 6 algebra. Now we have these 7 videos published in their entirety on YouTube, especially since algebra seems to be a problem area. And then you do have the others published partially. If you need access to those that are published partially, please see directions in the description below. We are now at section 7, relations, functions, and graphs. This section has 26 videos. Before we go on, recall I said that you need a good math textbook or maybe a set of 2, especially to get more practice questions. CSEC recommends these on the right here. From those, I would recommend these last 2 down here, which are these. Volume 1, Mathematics, a Complete Course with CSEC questions by Raymond Tulsi. And this is a picture of Volume 2. Please note this disclaimer down here. I get no financial or other benefits from the sale of these books. Also, as of late 2024, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only from paper 2. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions. This is the URL of that website. On the next page, you will see a print screen what the home page for that website looks like, which is this, the home page. You need to register first, and of course, subsequently you will sign in, but remember I said it is free. This is the URL here again. That URL will be in the description of this video below, so you can easily click on it and be redirected to this website. Another reminder that this formula sheet will be provided for CSEC math examination papers. This formula sheet you see on the left here. It is included in the syllabus, but just in case you don't have a full copy of the syllabus, there will be a link in the description below from where this formula sheet can be downloaded. This is the top part of that formula sheet, so you could see it a little closer, a little clearer. I am going to state the obvious here. You do not need to memorize these formulae on this formula sheet, as I said, this sheet will be provided during the examination. Of course, as you keep using these formulae, you will remember some of them. And this is the below part of that same formula sheet. While you do not need to memorize these formulae, you do need to know when and how to use them. So we are back to section 7, relations, functions, and graphs. These 5 objectives here have all been completed. Up to objective 9, those have also all been completed. Up to objective 13, those have also all been completed, some published totally on YouTube and some partially. We are here at this page. Objectives 14 and 15 have been completed, so we are now at objective 16. Objective 16. And then after that, we still have to go on to objective 20 and then 22 and finally up to objective 26. This section has 26 objectives. When we reach there, we would have come to the end of this section, section 7. So this is a reminder that we have finished up to objective 15, which would be 15 videos. Those have been published in their entirety, including this last one that I had not planned to publish in its entirety on YouTube. But there was a change in plan after completing this video for this objective and taking into account its level of difficulty. It was also published in its entirety on YouTube. And these others are published partially on YouTube. When I finish with this objective here, video 16, this will also be published in its entirety, according to plan. So we are here, objective 16. It says, derive the composition of functions. Now, this may be totally new to most of you. And it goes on to explain composite function of no more than two functions. For example, f, g, f squared, given f and g. You also need to know about the non-commutativity of composition functions. That is, f, g is not the same as gf in general. So, what do we mean by composite function? First of all, what is a function? As your syllabus points out, a correspondence in which each member of one set is mapped onto a member of another set. Now that is function. So this is a reminder. If f is the function such that x maps to x plus 4. So that there will be the domain, and this here will be the range. Consider a processing machine. Let's call it f. What it will do, it will just add 4 to whatever you put in it. So if you input these values, it will output, it will take 1, add 4 to it and output here, and then take 2 and so on. So you are going to get these values as output. So this here will be the domain, and over here, this will be the range. In this case, it is actually the range from the codomain. But you may also have the function g such that x maps onto 2x minus 3. G is a function such that x maps onto 2x minus 3. Okay, you can understand that. Problem is, what is fg or f of g? Some people say f circle g. What is f of g? This brings us to the concept of composite function. Not just function, composite function. Let me tell you what it is not. Fg is not f multiplied by g. We need to think of it as a new function, f of another function, which is g. So f of g. Do not confuse that with f bracket g. Composition of functions combines two or more. In this case, we are not doing more than two functions, like f of x, right? Do not confuse this f of x with that f of g. They are two completely different things. Like f of x and g of x, by plugging the output of the second function into the first, creating a new function often written as f o, f circle, f of g of x, or simply f of g of x, meaning f of g of x, where the output of g of x becomes the input for f of x, forming a chain that is input of x becomes the output of g of x becomes the final output of f of g of x. Don't worry if you don't understand that right now. As we go along, we will learn how to do them. The order matters. F of g of x is usually different from g of f of x. And I will explain all of those as we go along. So you have a function f such that x maps into x plus 4. And you have another function g such that x maps into 2x minus 3. What is fg? Now, this is how your syllabus listed, fg. In other books, you may see it as f of g, or you may see some brackets there. So remember, that is not f times g. And I will demonstrate that right now. If you multiply f and g like this, multiply them, you get this answer here. That's f multiplied by g. Normally you would think that is fg, but that is not fg. As I said, composite functions combines two or more functions like f of x and g of x by plugging the output of the second function into the first, creating a new function often written as f of g of x or f of g of x, meaning f of g of x, where the output of g of x becomes the input for f of x. So let's consider this carefully. If we want to find f of g of x, what we will do, remember g of x is this. F of x is that. So if we want to find f of g of x, we will take out that x there and put in this g of x in its place. So let's see how that goes. We know g of x is 2x minus 3. That is this. So substituting g of x in f of x of g, that is to say, here, we will take out that x. We will keep this 4 at the end, which is that 4 there. And where that x is, that x there, we will take it out completely and put in this g of x. So now we can simplify. F of x now becomes this f of g of x. You simplify that and you get 2x plus 1. Now remember what I told you about f of g is not the same as f multiplied by g. This is f of g. This up here is f multiplied by g. They are two different terms. And now, even when you consider the orders, f of g of x is not the same as g of f of x. So now let's go find g of f of x and see if we get this same thing here. If not, then we know that they are non-commutative. So now we are going to find g of f of x. G of f of x. So this is g of x. All we will do is take out this x from there and put in this f of x here, which is x plus 4. So that is the x plus 4. So now we have g of f of x. And we simplify that and we get this. Notice this answer, g of f of x, is not the same as this answer, f of g of x, which is not the same as if you were to multiply f and g. They are three completely different things. If you find this video useful and interesting, please like and share. Like and share. You may also consider subscribing to this channel. Let's consider that again. This time you have a function f such that x maps into 3x minus 4, and another one g such that x maps into x squared minus 2. Now what is fg? This is how your syllabus, this is how CSEC will write it. Now, I prefer to see an f of g, but let's go. It is not f times g, like that. Let's do that and see what we get. We get this answer here. We will compare that with the f of g and g of f as we did in the last slide. So as I said, composition of functions combines two or more functions like f of x and g of x by plugging the output of the second function into the first, creating a new function often written as f circle g of x, f o g of x, or f of g of x, meaning f of g of x, where the output of g of x becomes the input for f of x. So let us say we want f of g of x. Now this is f. This is g. What we will do, we will take out that x from there and put in this g of x. So we know what this is, g of x. So now that 3 there is this 3 here. This -4 is still that -4. All we are doing is removing that x from there, from here, and putting in g of x, which is x squared minus 2, which is this. So now the g of x becomes the input of f of x. And we simplify that, and we get this. Notice that answer down there is totally different from this one up here. But let's go a step further and deal with g of f of x. So we want g of f of x. So now we are going to substitute f of x in f of g. We know f of g is that where this x is, we will take it out and put in f of x, which we know is 3x minus 4. So we are taking the f of x and making that the input of g of x. And we simplify that and we get this answer over here, which is different from this one, which is different from that one. I'm just trying to make the point what we mean by composition of functions, and that f of g is not the same as g of f. Now let's look at this one. 3x minus 4 and 3x minus 4. Now this is the case where we are going to find f squared. We are going to use f, one f as the input to the other f. Written like that, almost like musical sign, f of f. Remember, it is not f multiplied by f. If we multiply those two, we get this. It is not that. So by now you know what this is all about. We will take one of these and substitute it for that x there. So we'll have f of x. And once we do that, now remember we still have this 3 in the front here, 3 in the front there. We still have this -4 in the back here. All we are doing is replacing that x, this x, with 3x minus 4, which is here. And you simplify that and you get 9x minus 16, which is certainly not this up here. Let's go the other way around with that. Well, you don't need to go the other way around. Normally, f of g of x is not the same as g of f of x, unless they are the same function. So since both functions are the same, then commutativity holds true. That's the exception to the rule. Other than that, f of g of x is not the same as g of f of x. Now for the rest of this video, we will consider 4 examples of composite functions. So example 1, we have these two functions here, f and g. You are told to find f g of x and then f g of -5 and g f of x and g f of -5. So really it's 4 things. So let's begin with the first one, f of g of x. So we will take f of x, which is this, we will substitute in that, for that x, this g of x, which is what we have here. We still have the 3 here. We still have the -1 here. We are just substituting this g of x in here for x, and we simplify and we get 6x plus 11. And of course, if we want to find fg of -5, then we replace that x there with -5. We simplify this and we get -19. Let's go the other way around. G of f of x. Now we know that this is f of x. We know that this is g of x. This time we want to find g of f of x. So we are going to take f of x, which is that, and substitute that for this x in here. So that 2 is still there. This plus 4 is still here. All we have done is remove that x on the right of that 2 and replace it with 3x minus 1. So this is what we have. We simplify that and we get this. We could factorize that. So we get 2 times 3x plus 1. And then g of f of -5. So we know what g of f of x is. It's this. If we want x to be -5, at -5, then we just replace that x with -5 and we get -18. Okay, that was example 1. Example 2, f is the function such that x maps into 3x minus 4 and g is the function such that x maps into 2x plus 5. We want to do 4 things here. We want to find f of g of x, and then we want to find f of g of -2, and then g of f of x, and then g of f of -5. So this is what we know this f of x function is. We know the g of x function is this. We want to find f of g of x. So we will take this g of x and replace it for that x in f of x. So we get that 3 there is still this 3 here. This -4 is still this -4 here. All we did was replace that x with this g function, 2x minus 5, and then you simplify and you get 6x plus 11. You want to find f of g of -2. So remember, we have f of g of x. And now the x is -2. So all we will do is substitute -2 for that x there, and we get f of g at -5 is -1. Now if we go the other way around, we are now finding g of f of x. So this is f of x, that's g of x. Now we will replace this x here with that up there. We are taking the f of x as the input to g of x. So this 2 remains the same for g of x. This plus 5 remains the same for g of x. Well, what we have done is replace this x here on the right of that 2x with f of x. Once we have that done, we just simplify and we get 3 times 2x minus 1. And then if we want to find g of f of -2, we know what g of f of x is. This time we will let x be -2. So we just replace x with -2, simplify, and we get -15. So if you compare the two things, they are not the same. That was example 2. Now for example 3. We have these two functions here. Function f such that x maps into 3x minus 2, and the function g such that x maps into 2x squared plus 3 here. We want to find f of g of x, so we will take g and make it the input for f of x. And then, of course, we want to find f of g of 4. So at this point, we will make the x 4. Then g of f of x. Now we will take f of x and make it the input for g of x. And then g of f of negative 1. So this is f of x. This is g of x. We want to find f of g of x. So where this x is in f of x, we will take it out and put in this g of x. So we still have that 3 there. We still have this negative 2 here. Replace that x there after the 3 with this f of g, which is this. Now that we have that, we can simplify and we get 6x squared plus 7. Of course, if we want to find the value of f of g at 4, so x is now 4, we just substitute in this expression here 4, simplify that, and we get 103. That is f of g of x. But now let's find g of f of x. This time we will keep g the same. That 2 is the same 2. That plus 3 is the same plus 3 here. And that square is the same square here. But where x is, we will put in this f of x, which is 3x minus 2. So once we do that, we simplify. You expand the square. You still have this 2 here and this plus 3 in the back here. And you further simplify by multiplying everything in this bracket by 2. And you get this answer here, which is g of f of x. It's a composite function. And then if you want to get g of f at negative 1. So if we have this function, f of g of x, and we let x be negative 1, then we just replace x with negative 1 everywhere we see it here. You simplify and you get 53. So it may take a little while to get the hang of this. I think you understand what is happening, but it may take a little while to actually master it. Finally, we are looking at example 4. P is a function such that x maps onto 3x minus 2, and v is the function such that x maps onto 2x plus 3. You are to find p v of x, or p of v of x, and pv of 6, or at 6, then vp at x, and finally vp at or of negative 5. So this is p of x, this is v of x. We want to find p v of x, so we are going to substitute everything here for v of x for that x there. So we get that 3 is still this 3, that negative 2 is still this negative 2, but where this x is, we will take it out and put in 2x plus 3, which is this. We can simplify that and we get 6x plus 7. That is p v of x. If you pinpoint x as being 6, So PV of 6, or you could say PV at 6. Then you substitute 6 for this x, simplify that, and you get 43. That was P of V of x. Now let's go the other way around, V of P of x. Now this time we are keeping the V intact, but we are going to replace this for P of x where this x is. So notice that 2 is still there. This plus 3 is still here. We have replaced this x in the middle here with 3x minus 2. That's this 3x minus 2. And then you simplify that and you get 6x minus 1, which is different from what we had over here. Finally, we want to find V of P of x of -5. Or as I said, you could understand that a little better if I said V of P at -5. So we are taking this x value as -5. We just substitute that x with -5 and you get -31. And that should suffice for this objective. As I said, this may look absolutely new to most of you, and it may take a little while to learn it. Derive the composition of functions, and you are to deal with no more than 2 functions, specifically f, g. That's how CSEC writes it. I wish they had said f of g, or f squared. You are given f and you are given g. Please be aware that fg is not the same as gf. It's not the same as f multiplied by g or g multiplied by f. It is not. That composition of functions are non-commutative. 2 multiplied by 3, in this case, is not 3 multiplied by 2 for composition of functions. That brings us to the end of video 16 based on objective 16 in section 7. This is an overview of how the videos from this section will be published. And you can clearly see that it is to be published in its entirety.